This video shows column packing and evaluation for large particle size, adsorbent media, manufactured by Mitsubishi Chemical Corporation, Japan, and having freeboard above the resin bed for backwash purpose. The adsorbent resin used in this case is widely used for purification of small and large molecules like antibiotics, vitamins, synthetic and fermentation-based pharmaceuticals, peptides, natural products, sugars, oils, and fats, and also for decolorization, debittering type of applications from small to large scale. This video will illustrate the following steps: adsorbent resin slurry preparation, typical column preparation, resin filling in the column, fluidization and fines removal, resin settling and downflow mode column packing, column qualification. In this video, we have used DIAION HP20 adsorbent resin, and slurry preparation solution is 20% volume per volume methanol. Adsorbent resins are supplied in semi-dry form with 55 to 65% moisture, and therefore we need a suitable packing solution to prepare the slurry. Here, 20% by volume methanol is used as packing solution. Methanol removes air from resin surface and within the pores and improves column packing. Let's start. Take required quantity of adsorbent resin in the beaker. Add 20% methanol and stir gently to suspend the resin. We have prepared 40 to 50% slurry of the adsorbent. You can see a lot of air escaping out from the slurry due to wetting of the adsorbent resin surface. Keep the slurry aside for 6 to 8 hours with intermittent stirring. After proper wetting, you will observe settled resin and clear liquid above the resin. Now, adsorbent resin is ready for column packing. Let us understand the background of column packing. The low-pressure column with large-size particles for purification applications consists of resins packed with free space above the resin bed for backwash purpose. These columns have top distributor and bottom collector system, and air vent, backwash nozzle. The distributor collector systems with desired micron rating with strainer on plate or header lateral design, and few others are generally used. Column needs to be connected to a pump chromatography system with pressure gauge and valves, etc., with required detector and sensors. We need these materials for column preparation. Column bottom collector plate is first fixed with the strainer of desired micron rating or frit, and this is then fixed to the column with a valve. Place the column in the place provided on the system or fix it to the stand. Connect the bottom valve and keep the column top open for filling the resin. Check that the column is in vertical position using spirit level, horizontally and vertically. Connect the column bottom to the pump with pressure gauge, placed after the pump or before column. Keep the packing solution, 20% volume to volume methanol, in the reservoir. Now, with the flow direction upward through the column, start the pump and allow the liquid to pass upward so as to remove the air from the bottom of the column. Fill the column to about 50% of its volume with packing solution. Now the column is ready for filling and packing of the adsorbent resins. Measure required quantity of adsorbent resin using measuring cylinder. In case of adsorbent resin that is DIAION HP20, packing factor of 1.03 to be considered while measuring the resin. Close the bottom valve of the column. Start pouring the resin slurry into the column. Resin particles will start settling down based on their density and particle size. Open the bottom valve and control the flow to allow the level of poured slurry to go down. Make sure that the column is not getting drained. Once the level inside the column goes down, add remaining quantity of the slurry. Then, with controlled outflow from column bottom, allow the resins to settle. When the liquid level is just above the settled resin level, stop the bottom valve. Fix the top plate with distributor. Connect the column top liquid inlet and air vent cum backwash line with valve. Mark the settled resin level. During fluidization with bed expansion index, which is ratio of expanded fluidized bed height, to settled bed height needs to be at least 1.2 to 1.5 for particulate fluidization, enabling better column packing. With upflow mode, bed expansion starts once the velocity of minimum fluidization is attained. Open the valve in the backwash line and column bottom inlet valve. Start the pump at low flow rate and allow the liquid to pass in upward direction for desired level of fluidization. Small fines with low density and particle size will move towards the top of the column as seen here. Keep increasing the upflow in discrete time intervals and watch the bed expansion index. After achieving sufficient fluidization, mark the expanded bed height and keep the flow rate constant to maintain particular expansion index for 30 to 45 minutes, allowing proper gradation of the resin particles. Resin fines can be removed by this fluidization as seen here. After this, stop the flow, close the bottom valve, and allow the adsorbent resins to settle. It will take 30 to 60 minutes. After settling, reduce the liquid level above the resin bed to about 5 centimeters above the bed by allowing controlled outflow from the bottom of the column. Close the column backwash line valve and open the bottom valve in controlled manner. Start the pump to pass the packing solution through the column in downward direction. Increase the flow in discrete steps to reach the flow velocity of more than 300 centimeters per hour, or 20% more than the operating flow, or up to 6 bed volumes per hour to pack the column. Maintain the liquid level above the resin bed. Observe that the settled bed is now constant and note the settled packed bed height. During the downflow, maintain the back pressure in the column to 1.5 to 2 bar to avoid draining of column, and also to obtain better liquid distribution leading to good column performance. Now this packed column is ready for next step. For column qualification, we need a suitable tracer, mobile phase, and a suitable detection system. 0.4 molar sodium chloride can be used as background mobile phase with 1 to 1.2 molar sodium chloride as a tracer and with conductivity detection. Alternatively, 20% ethanol can be used as background mobile phase with 1 to 2% acetone and 20% ethanol as a tracer and with UV detection. It is recommended to use 1% to 1.25% of column or bed volume as tracer injection volume to the packed column. Column should be first conditioned using background mobile phase. After this, tracer to be injected carefully just above the bed and allow the mobile phase to flow continuously through the resin bed. Column outlet should be monitored continuously using suitable detection system to obtain a peak profile. Flow velocity of 25 to 50 centimeters per hour can be used, but 30 to 45 centimeters per hour would be more appropriate. Plot of cumulative time or volume against detector response gives a peak profile, which is to be analyzed for asymmetry factor and HETP. Finally, with the acceptable packing of an adsorbent resin in the column, it can be used for process operations. Please note that this column packing procedure can be used for other adsorbent resins manufactured by Mitsubishi Chemical Corporation, Japan.